Hello and welcome to a new episode of TGIR. This is Season 1, Episode 8, and today, together with Gabriele Santomaggio, we are looking at how to enforce security to prevent churn and connection exhaustion in RabbitMQ. Now, we will break this topic into two parts because as we were preparing this TGIR, we realized as a single topic, it would result in a very long video. So we're splitting it in half. And today we'll be looking at how to secure publicly accessible RabbitMQ instances.
So yes, we will see how to expose RabbitMQ using Ingress. We are going to use Traefik. Traefik is one of the most famous Ingress in Kubernetes, and we will see how to configure the Ingress using TLS and TLS SNAI to redirect the traffic.
So Traefik will be deployed inside Kubernetes. We are provisioning a Digital Ocean Kubernetes cluster. This is something that was discussed in this issue with Stefano Vardanega. So Stefano, he's saying that he's using Digital Ocean to publish MQTTS on 883, but without Ingress. So he's interested in Digital Ocean, and that's what we're doing in this episode. So how do we start? We are in Season 1, Episode 8. We ran make DKE, which is using doctl, and the cluster either exists or it gets created. Region, size of the nodes, version, 3 nodes. In this case, we have already created this cluster 10 minutes ago. Okay, so once we have a Kubernetes cluster, what is the next step?
The first step is to install the RabbitMQ Cluster Operator.
Mm-hmm.
So it's make cluster operator. Then, this is.
So, okay, let's do that. After we deploy the cluster operator, the next step is to deploy a RabbitMQ cluster and expose it publicly using a load balancer. So we apply this, and while we wait for this cluster to create, let's have a look at this YAML. All it does is RabbitMQ cluster, single node, replicas 1, and we expose it using a service type load balancer. So this is using the RabbitMQ cluster CRD that we've seen earlier. Very simple. That's all it takes to deploy a single node Rabbit publicly exposed. Okay, so we're deploying a second cluster, and the only difference between one and the other, bugs, public YAML. So this is RabbitMQ bugs. And this is Bunny.
Yeah.
Exactly the same. The only difference is in the name. Exactly the same definitions. And these will create 2 clusters for us. So if we go RabbitMQ clusters, we have bugs and Bunny's just being created.
Yeah.
Okay, so we can see that we already have an external IP for bugs.
Mm-hmm.
We get an actual load balancer with an actual IP address. So if we access this IP address, I'm just going to open it in the browser, and I'm going to go to port, not HTTPS, 15672. We see the management, so it's publicly exposed, but the hint is here, right? It's in the actual browser address bar. It's not secure.
Yeah.
So we shouldn't send any login details. Don't do this. It's simple, but your credentials will be sent in plain text. So how about we try to connect to these IPs and just make sure that we are hitting the respective nodes. So for RabbitMQ bugs, to access it, we'll need to get to the secret, right? The default username and password. And for that, I mean, I kind of gave it away. It is a secret, bugs default user. So if I decode, which is X, we can see what the default user is. That's this one. And the password, which is this one. And if I log in, we confirm that the cluster is RabbitMQ bugs. And it has a single node. So that's the first one that we've deployed. And now let's have a look at Bunny. We use the same approach as before. So let's go to the service. We open this, the IP address of the load balancer, 15672. So this is Bunny. And to confirm that, we log in, same as before, Bunny default user, and default password. And we can see that this is the RabbitMQ Bunny cluster and the RabbitMQ Bunny node. Bugs, Bunny. Okay.
Perfect.
So it's working. It's publicly accessible, but it's not secure.
And another problem is that if we need more clusters, for example, if we need to instance more RabbitMQ clusters, we need a public IP for each single cluster, and this could be expensive, and sometimes could be very hard to handle all these public IP for each single instance.
Yeah, that's right. And that's something which bothers me from a waste perspective. We are wasting IPv4s, which are very scarce already. So we shouldn't do that. It would be great if we could use a single IP address for all our RabbitMQ clusters, especially if that IP address can service all the traffic that we need. I think that's another consideration. The load balancer may be a bottleneck if you have many clusters, high throughput clusters. So that is one consideration, but most users don't have that. Most users are not bottlenecked on the load balancer. So ideally, you should have a single IP to service all of them.
Let me add that even if it works without problem, this is not a best practice in Kubernetes to expose directly the service public. We in Kubernetes, the best practice says that you should put an ingress, then the root, and then the service. So in this way, if you want to change some things inside your cluster, you don't need to change anything from client side.
That is actually a very good point, because that's how you can do blue-green very easily. The IP stays the same. And that's something that you were mentioning for many months now, right? How to do blue-green. I think there's even like a proposal to look at Istio.
Yeah, exactly.
How to use Istio for blue-green RabbitMQ. But I think we're getting ahead of ourselves. But you made some, you remind me of that, which I thought was really cool when I first heard it. Yeah. Okay, so we have two RabbitMQ clusters with two public IPs, which are not secure. What is the next step?
Next step is to install Traefik.
Okay. So what we've done behind the scenes is we made a few changes while recording this to make it easier to know which are the correct steps. There are 7 steps involved, and that does not include the cleanup. So we did step number 1, where we installed the RabbitMQ Cluster Operator. That was the first step. And then we deployed 2 RabbitMQ clusters using this command with a public IP, but they're insecure. And that is now reflected in the target name. RabbitMQ Bugs insecure and RabbitMQ Bunny insecure. So the next step is deploy cert-manager for Let's Encrypt TLS certificates. So let's run that. Cert-manager. And all this does, it applies the YAML, which is version 1.1.0, and it takes it directly from, let's just wait for that.
Yeah.
Takes it directly from there. So that's all it does. The next step for us is to enable RabbitMQ TLS cert verification. So let's run that command in dry run mode and see what it does behind the scenes. In order to get Let's Encrypt certificates for RabbitMQ.com, we need to be able to verify the RabbitMQ.com domain. This domain is hosted on CloudFlare, so that's where the DNS is. And in order for Let's Encrypt to be able to issue certificates, we need to verify via DNS, via Cloudflare, that we own that domain. And we do that by providing a global API key from Cloudflare, which we store it as a secret, which enables the cert-manager, the Cloudflare issuer, to verify the RabbitMQ.com domain. And all that we do, we write that global API key to a file. It's a temp. It's not committed, obviously. We don't commit it. That would be bad if we did. But that's all it takes to do the connection between the Cloudflare, our DNS provider, or the RabbitMQ.com DNS provider, and cert-manager. So it can verify, so that Let's Encrypt can verify the domain before it issues certificates. We run this command, secret not found, it gets created, and that connects cert-manager, Let's Encrypt, and CloudFlare. So now that we have done step number 3 and step number 4, we can install Traefik.
Yeah, make Traefik. Yeah. Okay, as you can see here, Traefik is waiting for another public IP that this will be the IP address that we will use for redirect to the traffic.
Where will this load balancer route? Will it be RabbitMQ Bunny, RabbitMQ Bugs? But will it be the cluster IP?
If you want to see how it works internally, you have to open the YAML file that is called RabbitMQ Bugs Bunny Ingress HTTPS and AMQPS. If you open one of these, yeah, that's it. So as you can see here, we use the match, the host match, and we say, if you get a request from TGIR, blah, 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 etc., you have to redirect the traffic using on bugs, HTTPS on this port using this certificate. If you go inside the MQPS file, here we are using the host SNI match. The SNI is an extension for TLS, and you must, in this configuration, you must provide an SNI. When these two values match, the traffic will be redirected to the RabbitMQ bugs on the MQPS port. The endpoint, as you can see, is always the same. The endpoint is MQPS that we just saw inside the values file for Traefik.
We have Traefik here, AMQP, AMQPS, HTTP management, TLS, web secure. So these are all the, I'm reading here, AMQP.
So the MQP port that we see there is an error or a feature if you want, but we basically it doesn't work. If you try to access on this port, it will not work.
Okay, that's an interesting one. So let's see if we do that. Let's get the service.
So at the moment we don't have anything bound to this port. Okay.
Right. So the port is open.
The port is open.
Traefik is the one receiving those requests, right?
Yeah, exactly.
But it doesn't do anything with them.
Exactly.
And why is that?
Because as you can see here, we are going to deploy a RabbitMQ using the TLS configuration and disable not TLS listener. This is a new feature for the cluster operator. In this way, we disable all the not TLS port. So the standard port from IQP is disabled basically.
So 1.1.0, okay. I think this is the one spec. Thank you, Chuni, for adding this. She's the one that added the code and reviewed by Michal and David. Thank you. So what that means is that we disables non-TLS listeners. Okay, so everything which is non-TLS will be disabled, and that's what we're doing effectively. Okay, so yeah, exactly. MQTT, Stomp, all of these, yeah. Very nice. That's very, very nice. Okay, that's something new to me. Very cool.
Yes, let me add, there is a pull request that is called add support for Prometheus TLS. That the feature that we just saw use the standard Prometheus port. With this pull request, we will have also Prometheus in TLS.
That's very cool.
So everything with this pull request, when it will be merged, we will have everything in TLS, everything secure inside Kubernetes.
Very nice. Good. Okay. Are we waiting on anything else for this pull request?
We just waiting for someone that review the pull request.
Okay. Well, I started the review. I looked at it. I think that was the only thing was the comment, which you've done.
Yeah.
How about this?
Do you
Why
trust
not?
me?
Of course. Why not? Why wouldn't I? So confirm merge. Why not?
All right.
Okay. So by the time you're watching this TGIR, this may have already landed in a new version. Delete branch. Cool. Do we need to add any release notes, anything like that? Do you know?
I'm not following the release, and so I don't know.
Okay. So there you go. That is the merge. I'm expecting, like looking at this, the way these release notes are generated, I think these are automatically generated, which is very nice.
I think so. I really think so.
Yeah, so that's what we'll get. Okay, so 1.4.0, the next one should have it, right? That's the expectation.
Yeah, exactly.
And we are on 1.2.0, so how about we bump it live? Why not? Just like to show, I suppose, how easy it is to do this, right? So if we go to our makefile and we search for the cluster operator, we have versions. So if we bump this one to 1.3.0, this is what we've done. We went from 1.2 to 1.3.
Right.
And then let's just open a new window, make cluster operator. All this does, it will just apply make typo. Yeah, just to avoid any typos, if you source env, then you do make cluster operator, it will auto-complete by tabs. So we can see that this, all it does, it just applies the latest version, 1.3.0. We've updated the cluster operator to the latest available, 1.3.0. We raised an issue where we were expecting a rolling update to the stateful set. That did not happen. We went from 1.2 to 1.3. It feels like it behaves correctly. I mean, that's what I would expect to happen, so that a rolling update would not occur because there were no changes to the stateful set, to the maybe to the RabbitMQ cluster. There were some changes, even though I haven't seen anything. But the release notes are a bit misleading in that they are suggesting that a rolling update should have happened. So I was expecting to see that, and I didn't. So I just need to clarify, is it the release notes? How can we tell when an update to the cluster operator will result in a rolling update of the RabbitMQ clusters? I think that's a good one to know. Okay, coming back, we were saying that we have the two RabbitMQ clusters, the bugs and the bunny one. They're insecure. How do we make them secure?
We have Traefik. We have cert-manager. We installed the cert-manager CloudFlare. We did it. And now what we have to do is to change bugs and bunny to TLS. So let's try to do it live. It's make RabbitMQ bugs. No, that's it. Secure. Yeah, sorry. That's secure.
Successfully authorized the main, so that just happened. Yeah. Challenge finished. Yeah. Okay. Certificate. Now we have the certificate, RabbitMQ bug cert. If we describe, we'll see that the certificate is for TGIR. So that was created. And now if you look at the pods, we have the RabbitMQ bug server being updated. Let's open a shell on the actual pod. So S for shell, cd etc, cd RabbitMQ, ls, RabbitMQ conf. Do we write this to RabbitMQ conf? I think we do. There we go. So this is where we configure SSL, TLS cert, management. So the cluster operator does all of this for you, which is really cool, right? You don't have to worry about any of this stuff. It configures the SSL cert, which was provisioned by cert-manager, which was verified by Let's Encrypt, CloudFlare. All that is automatically done for you. RabbitMQ is configured with this certificate, the RabbitMQ node itself, Traefik is configured with this certificate as well. So we should be able to connect to this, to Traefik.
Just a moment. Not yet. I'd like to show you some things. Here we can see that we didn't specify any certificate yet, and Traefik will provide you a self-signed certificate from itself. So Traefik says, I don't have anything. I will provide my certificate. That for sure is not secure. Now we have Traefik, we have RabbitMQ, but we don't have the binding yet. If you execute make Traefik box ingress, in this moment, we join Traefik with RabbitMQ.
So now if you reload this, look at that. And now we have the certificate.
Now we have the certificate provided by Let's Encrypt with our domain and with TLS.
Okay, let's use RabbitMQ PerfTest to check if AMQPS works just as well. This trust manager trusts every certificate, effectively disabling peer verification. This is convenient for local development. So why do we have that?
We are not providing any certificate client side. We did the same in the Traefik configuration with skip verify. Do you remember? Basically here, the problem is between the Traefik and RabbitMQ. In this way, we accept TLS connection without verify the certificate. This because when we built the certificate, we didn't provide any IP address, any, how it's called, SAN certificate. And this is why we decide to do that. So this is mostly for test. If we want to do it in the right way, we should put the certificate in Traefik. When you configure Traefik, if you go inside, for example, the HTTPS AMQPS endpoint, here there is a way to provide a certificate. In this way, we should solve this problem. Client side for the AMQPS, this is a totally different problem because we don't provide any certificate client side. We don't provide anything. We just say this is a secure connection and that's it. We are not providing anything.
But isn't that where the trust store comes into play? So if we do have the CA certificates, the public ones, right? Then they should work. So why doesn't Traefik have the public certificates, the public CAs?
This is a bit different because when we use the browser, we use the public CI to validate our certificate. Okay. Yes. But when we use the AMQPS connection, we don't use anything. We just say this is a secure connection, but we don't validate anything. We just say this is a secure connection.
I see. And in order to do that, we need to provide the CA, right, against which to verify.
Yeah.
Okay.
This is what we are using in the simple way. We use factory use SSL protocol. Factory tells to set up the default key and trust manager for you, which don't do any from remote trust verification. This is the default that we have inside the RabbitMQ. By default, we have this option that by default is false. That is fails if not peer certificate. Okay. If we set this value to true, we are not able to connect in RabbitMQ in this way anymore. This is the default behavior. If you go back to the documentation, please, TLS, RabbitMQ TLS, if you go down, yes, as you can see here, we provide the key to connect to the RabbitMQ. Okay.
I see. And which key would we need to provide on client side?
We need to provide I need to investigate using our setup. I don't have an answer now. I will do that because it's interesting to understand how to do that.
Okay. Yeah, that is a good cliffhanger, I would say. Well, one of them, because we have a few more. So it'd be a nice, as a next step, as an improvement to this, how do we make it secured and verified? Because right now we only make it secure, but we don't verify it. So it is secure, it is encrypted, but it's not verified. And we would like to see how to do that.
The browser is verified because it's the browser that thinks to handle everything from the. Yes, that's it. Yes.
This is how it verifies certificates, and this is a certificate chain R3, ISRG root X1. This is something that ships with the operating system. Just to go back, we have, I think we haven't seen Bunny yet, so we've seen Bugs.
Bugs, yes.
We know that Bugs is using, if we were to just get out of here, to check what Bugs is using, we can do dig. We can use Bugs. That resolves to this IP address publicly. And this IP address is, if you look at the service, it's our load balancer.
Yeah.
Just this one right here. And if we were to look at Bunny, it will resolve to the same IP address.
Yeah.
So we're using the single IP address. And if we were to connect to Bunny, so we will go to Bugs, go to Bunny. We need to authenticate. So same as we did before, look at the secret. Bunny, default user, decode. So this is our other RabbitMQ node. We can see there's no queue defined here.
And no connection.
So no connection. So there is a queue, one queue, there are connections. So there's stuff happening on Bugs, but there's nothing happening on Bunny. We're using the same IP address, we're going through Traefik, but we're routed to this other cluster. That's the first thing. The other thing, we can try running PerfTest to see what happens now. So if we run PerfTest, where is it? So this was Bugs. We start another PerfTest instance against Bunny. And if we look at the pods, we have Bunny PerfTest.
Yeah.
If you look at the logs,
I have the
it's running. We can see, yeah. We can look into connections, PerfTest consumer, PerfTest producer, AMQP, SSL TLS. We have confirmation that's using SSL TLS. What else do we see? TLS version 1.2, exchange algorithm, client properties. Does he tell us? He doesn't tell us about SSL, but he does tell us separately, right? About SSL.
Can you just update one of the PerfTest and put another SNAI to show that it doesn't work?
That's actually a very good idea.
Yeah, let's, instead of SNAI, no, because you are using the connection and SNAI, the name. I'd like to connect with the wrong SNAI. So you need to use two strings.
Okay, we've done a typo.
Okay, exactly. If you try to execute it, you will see. Yeah, it fails as expected because there is no match between the TLS SNAI.
Okay, if we look at Traefik, so we'll go deployments, Traefik logs, what are we going to see?
So at the moment we have the bug logs. So there are.
So we see a lot of details, yeah. And we have the management open. So if we search for, is there like an error? Yeah, we do have a few errors. What are they saying?
Yeah, I think that is not connected. I think that is trying to connect, and yes, this is the error that we have.
Okay, so yeah, that is failing. We've proven that if we do change the SNI here, it will fail. Okay, so why do we use pass-through true? We're not terminating
No.
AMQPS connections at the proxy layer. Is that what this means?
Yeah. So basically, in this case, we just use the same connection to the client, and we terminate the connection on RabbitMQ side.
Right, and we don't. So we don't do double TLS. Right, Traefik in this case does not terminate TLS for AMQPS.
Exactly.
It does, however, terminate TLS for HTTP.
Yeah.
So we're doing TLS twice for HTTP, once at the Traefik side, once on the RabbitMQ side, but we're not doing it twice for AMQP.
If you comment the pass-through, it doesn't work, by the way.
It doesn't work if we comment the pass-through. Yeah, we can try that. If we comment the pass-through, yeah, it is bunny ingress. So this disables pass-through, and it's not going to work for MQPS.
Okay, it doesn't work. Yeah.
Okay, what do we see in the logs?
I already seen it in the logs that it doesn't work.
Timeout exception, okay. And so what is the problem here? Because we don't see a lot other than initialize the connection.
I expected to see some things inside logs, actually.
In Traefik, right?
Yeah. So nothing inside RabbitMQ, of course, because if we don't see anything inside Traefik,
there you go. So that failed. And we're not seeing anything in Traefik.
Yeah. Actually, this is interesting for troubleshooting because if you imagine that you have several services and you have some problem at the moment, if you are in this situation, it's extremely hard to understand what's going on. Basically.
Yeah, agreed. Because even if we have like some sort of a metric or something, because if we put something like Traefik in front of RabbitMQ and there's a problem with Traefik, how do we know that? Because we don't see anything on the RabbitMQ side.
Exactly. And I'd like to add another couple of points. At the moment, in RabbitMQ, with the SNI extension, everything works fine. The problem is that inside RabbitMQ, there is no way to understand what SNI the connection is using. So everything works, but we have to add some logs, some things to say, this is the MQPS connection, and this is the SNI that is using.
So you mean that in RabbitMQ, if we let's just take pods, let's take a RabbitMQ pod, let's go default. If we take bug server, for example, you mean we don't see the SNI?
Yeah. And this is, let me say, this is not our fault. This is actually a bug of the Erlang. When we try to look up the SNI values, we don't get anything, basically. We have undefined. When this bug will be fixed inside RabbitMQ, when there is an MQPS connection, you will see this is the MQP connection, username, etc., and this is the SNI that you are using. We found this bug where when we are recording, when we are trying to set up this environment.
Very nice. I love that.
Yeah, we found a couple of the interesting things during this this video, basically, when we try to set up all this environment. So, and I'd like to add another couple of things. If one user wants to try this environment and the user does not have the domain certificate, etc., you can set up everything using self-signed certification. Just instead of using let's encrypt, use a self-signed certification, and that's it. So it will work in the same way, exactly in the same way.
Yeah. So this is the one to use. Yeah. Self-signed issuer. That's a good one to know. Okay. So we have shown how to secure connections HTTP connections and AMQP connections to 2 RabbitMQ clusters using the same IP address. What we didn't do in this video, because we just didn't have time, is how to prevent churn and connection exhaustion. So I think that Traefik has something for HTTP that we can throttle how many HTTP connections are open, but we can't do the same for AMQP, because for TCP, it's just Traefik doesn't support that.
Yeah, if you see, all these parameters are for the HTTP.
Middlewares. So we have the HTTP, the rate limit, period, average. Okay. Where do we see TCP? So this is the HTTP and TLS. And these are all middlewares that apply mostly to HTTP. So we have nice control around whitelisting and things like that. I think it's more interesting to see what we have available for TCP, because that's what we use for AMQP. So all of these middlewares only apply to HTTP. Are there any middlewares that apply to TCP?
At the moment, no. We at the moment no, because let me say that in Istio the TCP party is new. Is some things that relatively
I
new.
see. This is what I was looking for. So we have in the documentation, HTTP routers can only target HTTP services.
Yeah.
And the routers are applied to the the middlewares are applied to the routers. So we need the router in order to apply middleware, and the router can only target HTTP services.
Yeah, exactly. What we are working on is to using another system, another service mesh that is called Istio, that is more complex. Istio uses the TCP connections and implements the TCP connection, SNI, etc., and also supports the way to limit the number of the connections, the rate, and stuff like that. So this will be maybe for another video to show how Istio works. Let me say that Istio is more complex, and we prefer to start with Traefik for a couple of reasons. The first one is because Traefik is one of the most famous. The second one, even if we spoke a lot, is extremely easy to understand how it works and how to configure it. The problem with Istio is that Istio uses the sidecar pod for each installation. So each call is redirected to the sidecar pod and then redirected to the real pod. So in this video, we showed how to do that, and we showed the limits. In the next video, we will see how to use Istio and why maybe in some cases you prefer to use Istio instead of Traefik. Because let me say that if you don't have a problem with lot of connections and security, maybe it's private, etc., I would prefer to use Traefik because it's easy. If I have to expose some things on internet and I have to create maybe a sort of the RabbitMQ as a service, maybe I think more in Istio instead of Traefik.
I was also wondering if when it comes to maximum connections, it's not something that the load balancer supports. So because we do provision an actual load balancer. So if we go back to here, Traefik, load balance, external IP, there is an actual load balancer sitting between Traefik and the internet. So when we define this service of type load balancer, could we provide some extra configuration that would maybe set the maximum number of connections on the load balancer?
We can, absolutely we can, but the thing is that let's suppose that you have 2 RabbitMQ instances, and for one instance you want to limit the number of the connection to 10, and for another instances you want to limit the number of connection to 100. Okay, this is the use case.
Right.
Same connection, same IP address, same load balancer, same secure policies, but I want to limit the number of the connection for one instance and for another instance.
Right. That makes sense.
Because it's totally true that you can limit the number of the connection using the load balancer, but it is totally global.
Yeah, for all RabbitMQ clusters. Yeah, that's right.
Yeah.
Okay.
You can do that, for example, use two IP addresses, one for instance, one for RabbitMQ cluster, for example, and you can configure the load balancer. But the aim of all this configuration is to use always the same IP address, even if you have 10 or 20 RabbitMQ clusters.
How do we finish? How do we clean up? What is the last step?
So the last step basically is to clean up everything and clean up.
There's a make clean, which tries to apply things in reverse. Okay, and when everything's done, we can DKRM, and they just use doctl to remove the cluster. Let's do that. Yes. With that, we're done. Another episode wrapped up. Thank you, Gabriele, for joining me. This was really helpful to go through all the different things. Even though Traefik is simple, and even though what we've done is simple, it just goes to show that actually there's so much to it. And it's simple from some respects, but there's still like a lot of moving parts. Imagine if you had to do this differently. Imagine if you didn't have these YAMLs, these declarative manifests to apply, and for everything to converge. How difficult would that be? I remember doing something similar. It was way, way more difficult than this. It would not have taken 18, 20, 30 minutes. It would have taken hours and hours. And the nice thing is that you can run the same commands and it should work, right? With a few adjustments.
Yeah. I think that, as I said before, if you want to try this using Minikube, is not complex. It's enough to replace the Let's Encrypt with self-signed certificate using always cert-manager, and it will work. All
right. Thank you for watching. See you next year. This is, well, it's the last episode that we record, episode 8. There's another one that we have recorded, so that will be the last one in the series, season 1 of TGIR. But next year we'll start with season 2, and we'll see what happens. So future episodes, let us know what you want to hear, what you would like us to cover. And Happy New Year. Any last words, Gabriele?
No, Happy New Year.
Happy New Year. All right. See you in season 2.
All right. Bye.